So for this lesson, we are going to go back and do a little bit more with differential equations. And these are probably the most complicated types that you're going to see, and they all deal with direct proportion. So we have talked about that they might say something about a rate. So for now, I'm going to call that dy dt is equal to a proportional statement. So we use the constant k to show that something's proportional. That means you're multiplying by something. And I'm going to use y as my function for this. So I'm just going to do some labeling. This is our rate. And k is our constant of proportionality. And then y is our function again. So if I were to solve something like this, so I'm going to take the integral of this because I want to undo the derivative. We're going to go through all of our steps that we did before. So I'm going to separate the variables. So first thing I always do again is to cross multiply. And the only thing I got to move over to the other side is this y. So this becomes 1 over y dy equals k dt. Now I'm going to take the integral of that. The integral of 1 over y is the ln of y. The integral of k, if I'm integrating with respect to t, is kt plus c. And then last thing we always do is solve for y. So I'm going to take the e to both sides. And I'm actually going to drop the absolute value because technically when you have e to something, it's always going to be positive. So y equals e to the kt plus c. And we've talked about the fact that when we have a constant in the exponent, we can move it out to the front. So y equals ce to the kt. Now that actually follows along with the theorem that we have for exponential growth and decay. Y equals ce to the kt. It's actually always going to be our solution of a differential equation that's a direct proportion. So I'm going to label this a general solution. So if you can remember that's going to be the answer every time you have a direct proportion, you don't have to solve for that. You can go right to writing that down. But it's definitely easy to take the integral of this and come up with a general solution if you forget. So I'm going to do that a couple times, but then after that, we're just going to use the general solution that we'll remember. So I'm going to go to example number 1 here. It says, the rate of change of y is proportional to y. When t equals 0, y equals 2. When t equals 2, y equals 4. What is the value of y when t equals 3? So that seems like a lot of information. So I'm just going to write down my differential equation. That comes from the first statement right here. The rate of change of y is proportional to y. And I can see that they're using time. So I'm going to say dy dt equals, it's proportional, so k y. Now, I can skip to this part right here, but if I forget, I'm going to cross multiply. So dt, scratch that, dy is equal to ky dt. But divide that y over, 1 over y dy equals k dt. I'm going to take the integral of both sides. So the ln of y is equal to kt plus c. I'm going to do e to both sides, and I'm going to remember the fact that c can come out in front, so that's ce to the kt. So there's my general solution. Now they give us a bunch of givens here, actually 2 sets of givens. I always want to use the one with the 0 in it first because 0 helps us to eliminate some things and hopefully helps us solve things a little bit faster. So what I'm going to do is I'm going to plug in these values into my general solution here. So y is 2 when t is 0. So if I solve this, that's e to the 0, which is 1. C actually is going to equal 2. So now I know what C is. I'm going to take that and write a new general solution. Y equals 2e to the kt. I know a little bit more information about this. So now I'm going to use my second set of givens. I'm going to plug 4 in for y and 2 in for t. So actually now I can solve for k. That's the only variable left that I don't know. So I'm going to divide by the 2. That gives me 2 equals e to the 2k. I'm going to take the ln of both sides. So the ln of 2, these cancel, equals 2k. Divide by 2. K would equal the ln of 2 over 2. Now those 2's can't cancel. This is going to be some decimal. I'm going to leave it like this for now so that I don't end up rounding till the end. So I know what K is, I know what C is, I can write my solution, my general solution now. Y equals C, which is 2, e to the K, which is the ln of 2 over 2, times t. So actually this is my particular solution. So the last step, we're going to find y when t equals 3. So I'm going to plug in 3 for t. And now if you were on the multiple choice question of a AP exam, you would just look for that in your answer. But we have our calculators for this one, so I'm going to just type it in, 2e to the ln of 2 divided by 2 times 3. That looks pretty good. That gives me 4 root 2, but I'm going to convert that to a decimal. So y is approximately 5.657. Okay, on to the next one, number 2. So the rate of change of v is proportional to v. So dv dt is proportional to v. So I'm going to actually skip some steps here because if I go and solve that, I'm going to just get the same answer that I got before. So v is equal to ce to the kt. Now we have some givens again. I'm going to use the 0 first. So I'm going to plug in 20,000 for v and 0 for t. So again, e to the 0 is 1, c is 20,000. So my new general solution, because now I know c, v equals 20,000 e to the kt. So now I'm going to use my second set of givens and plug those in. 12,500 for v and 4 for t. Okay, so next step, we're going to solve for k. That's our value that we don't know. So I'm going to divide 12,500 by 20,000, and that gives me 5/8. Take the ln of both sides. So ln of 5/8 equals 4k, and divide that by 4. K would be the ln of 5/8 divided by 4. So my new particular solution is v is equal to 20,000 e to the k, and I just solved k, the ln of 5/8 over 4 times t. So the last value that we're going to find, the value of v when t equals 6. So the last thing I'm going to do is plug in 6 for t. And I'll give you a minute. Go ahead and plug that into your calculator. You can pause it. And that is going to give you 9,882.118. Okay, on to the back. Let's take a look at number 3. Suppose that 10 grams of the plutonium isotope Pu-239 was released in the Chernobyl nuclear accident. How long will it take for the 10 grams to decay to 1 gram? So this is going to be a direct variation question. So I'm just going to skip right to the fact that y equals CE to the KT. Y is going to represent, we'll let that represent our mass of plutonium, and T will be our time. And that will be in years. So one thing we would have done is looked up the half-life of plutonium. So I'll give you that. The half-life of plutonium is going to be, so if we're starting at, let's see, 10 grams, the half-life, so that would put us at 5 grams, would be 24,100 years. Okay, we also know that we're starting at 10 grams, so y equals 10 when t is 0. So let's plug in what we know. I'm going to start with the one that has the 0 in it. So y is 10. C would be 10 because e to the 0 is 1, c is 10. I'm going to rewrite that. Y equals 10 e to the kt. And now I'm going to plug in my second set of givens. So when y equals 5, t is 24,100. I can solve for k now, so that's 1/2. Take the ln of both sides and divide. So k is equal to the ln of 1/2 divided by 24,100. Okay, so I'm going to make my particular solution now. So I have my c and I have my k. So y equals 10e to the ln of 1/2 divided by 24,100 k. Oh, sorry, that should be a t. Okay, so how long will it take for the 10 grams to decay to 1 gram? So I want to plug in 1 for y, and I'm going to be solving for t this time. So I'm going to divide by 10. Undo the e by taking the ln. So now at this point, what you're going to be doing is solving this on your calculator, the left side, and then dividing by this number right here. So go ahead and pause it and solve that, and then you can check your answer. So your answer is going to be approximately 80,059 years. Okay, on to the last question, number 4. Suppose an experimental population of fruit flies increases according to the law of exponential growth. There were 100 flies after the second day of the experiment and 300 flies after the 4th day. Approximately how many flies were in the original population? Okay, so I'm going to use my y equals CE to the KT. And I'm going to write down some givens. So there are 100 flies after the second day and 300 flies after the 4th day. Okay, so I'm going to plug in some information. The problem is I don't have a 0. So I'm going to pick one. I'm going to use the first one here. So I'm going to plug in 100 for y and 2 for t. So normally we solve for c, so I'm still going to do that just like I normally would. So I'm going to divide both sides by e to the 2k. So c would equal 100 over e to the 2k. And what I would normally do next, right, we would plug back in for c up here. So let's do that. Y equals 100 over e to the 2k times e to the kt. And then our next step is we go ahead and we plug in our second set of givens. So I'm still going to do that. It just looks a little funky because I have an extra variable in here, right? We still have the k, but I mean, technically we solved for the c, so we're plugging that in. So I'm going to plug in my second set of givens. 300 is my y. And t is 4. So if we remember from Algebra 1, when we technically were dividing these because this is in the numerator and this is in the denominator, I subtract my exponents. So that would be 300 equals 100. 4k minus 2k is 2k. So now I can solve for k. I divide by 100, that gives me 3. Take the ln of both sides and divide by 2. Okay, so now I have enough information to write somewhat of a solution. Y is equal to, I still don't know what c is, c, e, but I do know what k is, the ln of 3 over 2 times d. Okay, so the question is asking approximately how many flies were in the original population. So I've got my equation here. I still don't know what c is. That's kind of the tricky part. So what I can do is I can redo my given from the first one and hopefully help me solve for c. So y is 100. I'm going to replug in that 2 for t. And it looks like I'll be able to solve for c. So these 2's cancel. 100 equals c e to the ln of 3. And we know that rules from e's and ln's, we can cancel those out. Bring that 3 down, so that's 100 equals c times 3. And I can divide by 3. C would give us approximately 33.3 repeating. So now I can write my particular solution. I know c, I know k. Y equals 33.3 repeating, e to the ln of 3 over 2 times t. So if I want to know what's in the original population, I'm going to plug in 0 for t. And this would give us 1. So our original population is approximately 33.3 repeating. But we always round when we have people or animals, so I'm going to say that's approximately 33 fruit flies. So we're at the end of the video. Feel free to go back and pause anything, rewatch something, email me if you have any questions.